As we speak, the night sky is undergoing profound changes that will transform its appearance within decades, if not years. Experts and astronomers around the world, including renowned personalities such as Neil deGrasse Tyson, have raised the alarm. Polaris, a star that has long held a central position in the night sky and defined its uniqueness as the North Star, is about to undergo a drastic change. The story behind this event is both fascinating and disturbing. Polaris' central position in the night sky has defined its uniqueness as the North Star until now. This star was a constant reference point for stargazers, navigators, and astronomers. However, this stability could soon be altered significantly, transforming both our night sky and the astronomical measurements we are accustomed to. Polaris has long been considered the guiding star that leads the way, a beacon revered by astronomers and navigators throughout the centuries. Its constant presence in the firmament has been fundamental to celestial navigation. Throughout history, Polaris has played a significant role in navigation, culture, and science. Ancient mariners used it to navigate the vast oceans, and it has been a symbol of constancy and reliability in many cultures. However, all this could suddenly change. A recent study presented by the respected Royal Astronomical Society in September 2023 has raised uncertainty about the future of this bright star. Polaris is on the verge of an explosion that will cause it to disappear permanently from the night sky. Before we delve into the implications of this revelation, let's take a closer look at the star in question. Polaris, also known as the North Star or the Pole Star, occupies a special position in the sky because of its proximity to the celestial North Pole. It is almost directly over the Earth's North Pole, which gives the illusion that it remains static in the northern sky. The star is located in the constellation Ursa Minor, also known as the Little Dipper. Polaris is a star of moderate brightness that stands out as a yellow-white supergiant of considerable dimension compared to our Sun. Despite its appearance as a lone star, it is actually part of a rather complex triple star system. Within this system, the primary stars are Polaris Aa and Polaris Ab, which to the naked eye look like a single star. In addition, there is a third companion, Polaris B, orbiting this binary pair. The gravitational forces between these stars shape their orbits and affect their individual behaviors, which has a direct impact on their brightness and other notable characteristics. Polaris is approximately 323 light-years from Earth, which means that the light we receive from this star today was actually emitted 323 years ago. This means that if Polaris were to explode today, we would not be aware of it until 323 years later. Therefore, when we finally witness this event from Earth, more than 3 centuries would have elapsed since it occurred. The scientific projections are based on the empirical evidence available at present, which implies that it is plausible that Polaris has already experienced an explosion, but we have not yet received the light from that event. Throughout history, the North Star has played a significant role extending through various civilizations and eras. Its value is cultural, symbolic, and crucial to navigation. Its stability and immovable position near the celestial North Pole have made it an invaluable tool for ancient mariners and travelers. This star has acted as a lighthouse, allowing precise orientation and navigation. In some social groups, the North Star represents the idea of constancy and solidity, perceived as an element that has remained unchanging amidst the celestial ballet that makes up the night sky. Recently, this star has exhibited behavior out of the expected. This disturbing alteration in its pulsation cycle has puzzled astronomers, prompting further analysis of this celestial anomaly. Instead of following the predictable pulsation pattern, Polaris has adopted an unpredictable and erratic cycle of dimming and brightening. This variation has raised concern among scientists who warn that the star may be nearing the end of its life. This change is consistent with the behavior observed in stars as they near the end of their existence. The progressive increase in the pulsation times of Polaris, which was previously stable in its dimming and brightening cycle, could be attributed to the interactions between the star and its system. Notably, we have observed an unusual increased pulsation duration of approximately 4.5 seconds. Although seemingly insignificant, this change is of great significance. Some astronomers have cautiously suggested that gravitational forces between Polaris stars could be the cause of these fluctuations in the star's atmosphere, directly affecting its pulsation patterns. However, others are firmer in their belief that the star is close to its explosion. This suspicion is based on the striking similarities between the mysterious behavior of Polaris and Betelgeuse. Betelgeuse, another prominent star in the Orion constellation, has shown puzzling alterations in its brightness, leading to speculation about a possible imminent explosion. Several experts have warned of the star's inevitable end, emphasizing its fluctuations in brightness and behavior patterns similar to those of stars that have reached the end of their life cycles. NASA has shown great concern about the anomalies presented by Betelgeuse. Although NASA has expressed strong interest and vigilance towards the unusual behavior of Betelgeuse, it has not made an official announcement of similar monitoring concerning Polaris. Stars undergo an extensive journey through different stages in their evolutionary cycle. When new, these stars have relatively low temperatures and brightness. Subsequently, they advance to the main sequence phase marked by nuclear fusion, where they remain stable for billions of years. Finally, as their hydrogen fuel is depleted, they enter the red giant phase, where they experience a rapid increase in temperature and brightness. This phase sees a dramatic increase in energy output before reaching a catastrophic explosion. If Polaris were to experience a supernova, we would surely witness an amazing event in our sky. The star would become incredibly luminous, eclipsing even the brilliance of the moon and becoming one of the brightest objects in the night sky. This luminous spectacle could last for days, weeks, or even months. The star's visual appearance would undergo drastic changes, transforming into a dazzling point of light or a temporary bright object, potentially manifesting colors before fading. This visual display could momentarily alter our familiar perception of the constellations Ursa Major or Ursa Minor, since Polaris is actually the North Star and is part of these stellar groupings. As for our safety, we would be completely safe. Given the size and distance of Polaris, it is likely that the Earth would not be affected even in the event of a stellar explosion. Visually, although a Polaris supernova may not be as spectacular as Betelgeuse, it could be visible to the naked eye for a long period and outshine nearby white stars. Understanding the significance of Polaris requires an appreciation of its role in history and navigation. For centuries, Polaris has been a crucial guide for travelers and explorers, helping them find their way across oceans and deserts. Its fixed position in the night sky has provided a reliable point of reference, allowing navigators to determine their latitude and direction. This has been particularly important in the northern hemisphere, where Polaris is most visible. Polaris' importance extends beyond practical navigation. In various cultures, it has been imbued with symbolic meanings. For the Vikings, it was a guiding light on their voyages. In Chinese mythology, Polaris was known as the Emperor's Star, symbolizing the central authority of the emperor, mirroring its central position in the sky. Native American tribes also revered Polaris, seeing it as a constant presence in a changing world. The star's unwavering position has made it a symbol of stability and reliability in many cultural narratives. The current changes observed in Polaris behavior are alarming not just because of their potential impact on navigation and astronomy, but also because they challenge our understanding of stellar life cycles. Stars like Polaris are expected to follow relatively predictable patterns. The unexpected changes in its pulsation cycle suggest that there may be factors at play that we do not fully understand. This has led to increased interest and study among astronomers, as they seek to unravel the mysteries of this important star. The comparison with Betelgeuse is particularly telling. Betelgeuse, a red supergiant in the Orion constellation, has also exhibited unusual behavior in recent years. It has shown significant dimming and brightening, leading to widespread speculation about its imminent explosion. Betelgeuse is much closer to the end of its life cycle than Polaris and is expected to go supernova within the next 100,000 years. The similarities in behavior between Betelgeuse and Polaris have led some scientists to speculate that Polaris may also be closer to its end than previously thought. The potential explosion of Polaris would be a monumental event in the field of astronomy. Supernovae are among the most dramatic events in the universe, releasing more energy in a few seconds than our Sun will emit in its entire lifetime. The explosion of Polaris would provide a wealth of data for astronomers, helping them to better understand the life cycles of stars and the mechanisms behind supernovae. It would also be a spectacular event for stargazers, offering a once-in-a-lifetime opportunity to witness a supernova with the naked eye. Despite the potential scientific benefits, the loss of Polaris would be significant. It would mean the loss of a crucial navigational tool and a symbol of constancy in a changing world. The disappearance of the North Star would require adjustments in navigation techniques and a re-evaluation of our understanding of the night sky. It would also have cultural and symbolic implications, as people around the world grapple with the loss of a star that has been a constant presence for millennia. The scientific community is closely monitoring Polaris, using a variety of tools and techniques to study its behavior. Telescopes around the world are being used to observe its pulsation cycles, brightness, and other characteristics. Astronomers are also using data from space-based observatories to get a more detailed view of the star and its surroundings. These observations are helping to build a more complete picture of what is happening to Polaris and what we might expect in the future. In conclusion, the changes in Polaris behavior are a cause for concern and excitement in the scientific community. While the potential explosion of the North Star would be a significant loss, it also offers an unprecedented opportunity to study a supernova up close. The event would have profound implications for our understanding of stellar life cycles, navigation, and our cultural relationship with the night sky. As we continue to monitor Polaris, we can only wait and see what the future holds for this iconic star. Whether it explodes tomorrow or in 1,000 years, Polaris will continue to capture our imagination and inspire our curiosity about the universe. Polaris is not just a single star, but a multiple star system composed of 3 stars. The primary star, Polaris Aa, is a yellow supergiant of spectral type F7, with an apparent magnitude of 1.97, making it the brightest star in the constellation of Ursa Minor. It is about 2,500 times more luminous than our Sun and has a radius approximately 46 times that of the Sun. Polaris Aa is a classic example of a Cepheid variable star, meaning its brightness varies in a regular cycle due to pulsations in its outer layers. These pulsations are caused by the complex interplay of gravitational forces and nuclear fusion processes occurring within the star. The secondary component, Polaris Ab, is a smaller star that orbits Polaris Aa at a close distance. Polaris B, the third star in the system, is a main sequence star that orbits the pair at a much greater distance. This hierarchical system creates a dynamic environment where gravitational interactions can significantly impact the behavior of the individual stars. Polaris' status as a Cepheid variable star is of particular interest to astronomers. Cepheid variables are crucial for measuring cosmic distances because their intrinsic luminosity is directly related to their pulsation period. This relationship, known as the Leavitt law or the period luminosity relationship, allows astronomers to determine the distance to Cepheid stars with high precision. By observing the pulsation period and apparent brightness of a Cepheid, its distance can be calculated. This method has been instrumental in establishing the scale of the universe and measuring distances to galaxies far beyond the Milky Way. The pulsation period of Polaris has been changing, which is unusual for a Cepheid variable. For many years, its period was steadily decreasing, but recent observations have shown that it has started to increase again. This erratic behavior has puzzled astronomers and led to intense scrutiny. The changes in pulsation period suggest that Polaris is undergoing significant internal changes, possibly related to its evolution towards the end of its life cycle. Polaris' importance is not limited to its role in navigation and astronomy. It also holds a significant place in various cultural and historical contexts. Throughout history, Polaris has been a symbol of guidance and reliability. Ancient mariners used Polaris to navigate the seas, and its consistent position in the sky provided a reliable point of reference. The star's fixed position made it an essential tool for determining latitude, helping sailors to traverse vast oceans long before the advent of modern navigation technology. In Greek mythology, Polaris is associated with the story of the little bear, Ursa Minor. According to the myth, the nymph Callisto was transformed into a bear and placed in the sky by Zeus. Polaris marks the end of the bear's tail. The Romans also used Polaris for navigation, referring to it as Stella Maris, or the Star of the Sea. In Chinese astronomy, Polaris was known as the Emperor's Star and was considered the center of the heavens. It symbolized the emperor's central role in maintaining order and stability in the empire. The emperor's palace was often aligned with Polaris to reflect this celestial order. Native American tribes, such as the Lakota Sioux, saw Polaris as a constant and reliable presence in the sky, representing a guiding spirit. The star was also used in traditional storytelling, where it played a role in guiding lost souls and travelers. The recent changes in Polaris behavior have led to renewed interest and investigation in the scientific community. Using advanced telescopes and space-based observatories, astronomers have been able to study Polaris in unprecedented detail. Observations from the Hubble Space Telescope, for instance, have provided valuable data on the star's pulsation cycles and brightness variations. One theory suggests that the changes in Polaris' pulsation period could be due to interactions with its companion stars. The gravitational forces exerted by Polaris Ab and Polaris B could be causing disruptions in the primary star's outer layers, leading to the observed variations in brightness and pulsation. Another possibility is that Polaris is undergoing internal changes as it evolves towards the end of its life cycle. As a star exhausts its nuclear fuel, it can undergo dramatic changes in size, temperature, and brightness. These changes can manifest as variations in the star's pulsation period and overall behavior. The study of Polaris also contributes to our understanding of stellar evolution and the mechanisms that drive Cepheid variable stars. By observing and modeling these stars, astronomers can gain insights into the processes that govern stellar life cycles, from formation to eventual demise. The data collected from Polaris can also be compared with other Cepheid variables to identify common patterns and anomalies. If Polaris were to go supernova, it would be one of the most significant astronomical events in recent history. A supernova explosion occurs when a massive star exhausts its nuclear fuel and can no longer support its own weight. The core collapses, leading to a violent explosion that ejects the star's outer layers into space. The resulting supernova can outshine entire galaxies for a brief period and leave behind a dense core, such as a neutron star or black hole. For Earth-based observers, a Polaris supernova would be a spectacular sight. The explosion would make Polaris much brighter than it currently is, potentially becoming visible even during the day. The light from the supernova would travel across space and reach Earth, providing a unique opportunity to study the event in real time. Astronomers would be able to observe the different phases of the supernova, from the initial explosion to the fading of the remnant. The potential explosion of Polaris would also have implications for our understanding of supernova mechanisms. Studying the light curve, spectrum, and other characteristics of the supernova would provide valuable data on the physical processes involved. This information could help refine existing models of stellar evolution and supernova explosions. The study of Polaris and its potential explosion fits into the broader context of astronomical research and our understanding of the universe. Stars like Polaris are crucial for measuring cosmic distances and establishing the scale of the universe. By studying Cepheid variables, astronomers can map out the structure of our galaxy and beyond, identifying patterns and structures that shape the cosmos. The potential explosion of Polaris would also provide a unique opportunity to study the effects of supernovae on their surroundings. Supernovae play a critical role in enriching the interstellar medium with heavy elements, which are essential for the formation of new stars and planets. The shock waves from supernovae can trigger the collapse of nearby gas clouds, leading to the birth of new stars. By observing the aftermath of a Polaris supernova, astronomers could gain insights into these processes and their impact on the surrounding environment. In addition to its scientific significance, the potential explosion of Polaris would have cultural and symbolic implications. The loss of the North Star would be a profound event, marking the end of an era in human history. For centuries, Polaris has been a symbol of constancy and reliability, guiding travelers and inspiring stories across cultures. Its disappearance would be a reminder of the ever-changing nature of the universe and our place within it. The changes in Polaris behavior and the potential for its explosion are both exciting and sobering. As scientists continue to monitor and study this iconic star, we are reminded of the dynamic and ever-changing nature of the universe. Polaris has been a constant presence in our night sky for centuries, guiding travelers and inspiring wonder. Its potential explosion would mark the end of an era, but it would also provide a unique opportunity to advance our understanding of stellar life cycles and the mechanisms behind supernovae. Whether Polaris explodes tomorrow or in 1,000 years, it will continue to capture our imagination and inspire our curiosity about the cosmos. The study of this remarkable star offers a glimpse into the complex and dynamic processes that shape the universe, reminding us of the delicate balance between constancy and change in the celestial ballet that unfolds above us. Cepheid variables, like Polaris, are not only important for their navigational and cultural significance, but also for their crucial role in astronomy. These stars are used as standard candles to measure cosmic distances, thanks to the well-established relationship between their pulsation periods and intrinsic luminosities. This relationship, known as the Leavitt law, was discovered by Henrietta Swan Leavitt in the early 20th century and has since become a cornerstone of modern astronomy. By observing the period of a Cepheid's brightness variations, astronomers can determine its absolute magnitude. Comparing this with the apparent magnitude observed from Earth allows the calculation of the star's distance using the inverse square law of light. This method has been instrumental in measuring distances within our galaxy and to nearby galaxies, helping to establish the scale of the universe and map its structure. The use of Cepheid variables extends beyond distance measurements. They also provide valuable insights into the processes of stellar evolution. By studying the pulsation mechanisms of these stars, astronomers can learn about the internal structure and dynamics of stars. This, in turn, helps to refine